One final common structure that we are going to work with this week involves combining a parallel combination in series with in series with another resistor. In other words, we have current coming through the 1K ohm resistor, splitting and going into these two parallel resistances. We want to determine the voltage, call this V1, across the 1K ohm resistor, and we want to determine the voltage across this parallel combination. Since they're in parallel, the voltage across here, across the 22K ohm resistor, is the same as the voltage across the 10K ohm resistor. And we're going to call the voltage across that then V2. To do this, let's demonstrate how we can use our understanding of combining two parallel resistances into an equivalent single resistor. In other words, we want to combine those two so that we will have then, at least for analysis purposes, our 1 kilo ohm resistor in series with the parallel equivalent, let's call it R sub P, where R sub P is the parallel combination there. R sub P then, from our previous videos, we know that the parallel combination is equal to that resistance, or 10 times 22K divided by 10 plus 22 kilo ohms. And the combination of those then is equal to 6.875 kilo ohms. And as a consistency check, it's always good after doing these calculations just to make sure that you got it in the right order. The equivalent resistance must be less than the smallest of the two parallel resistors. Well, the 10 kilo ohm resistor is the smallest of these two, and 6.875 kilo ohms is less than that. So at least that answer is consistent with what we know about parallel resistances. Now, R sub P then equals 6.875 kilo ohms. And we can now, through this equivalent circuit, we can determine the voltage across this resistor. We can determine the voltage across this equivalent resistance. Again, we called this plus to minus V1, and we called this voltage here V2. So pause the video now for just a second and look at what we're saying. V2, the voltage across these two parallel resistances, can be determined by finding the voltage V2 across the parallel equivalent of those two resistances. We can go through and we can do the calculations. This is a 12-volt source. We then know that V2 is going to equal 12 times, V2 is the voltage across here, V2 is going to equal 12 times the equivalent resistance of 6.875 divided by 1 plus 6.875, and that turns out to equal 10.476 volts. Similarly, we can calculate V1, the voltage across the 1 kilo ohm resistor. That's going to be 12 times 1K divided by 1 plus 6.875. And that then equals 1.524 volts. And again, for consistency, let's just point out then that the voltage drop across here plus the voltage drop across here has got to equal to 12 volts, or V2 plus V1 is equal to 12 volts.